Hey guys, welcome to Unit 8 Lesson 5. Our topic today is log derivatives. Pause the video and try the warm-up. The warm-up says if y equals ln of x, solve for x, and then find the derivative using implicit differentiation. So, I want to solve this for x. How do I do that? How do I solve a log equation for x? Remember, ln is same thing as writing log base e. So, if I convert it into exponential form, it'll be what? X is equal to e to the y. I hope you remember it. Circle the base and then you go to the other side, right? So now it wants us to take the derivative with respect to x. It'll be 1 equals e to the y times dy over dx, right? So solve for dy over dx. That's what we're trying to find. It's 1 over e to the y. I already know my e to the y is equal to what? 1 over x. We found that in the first step, right? So this is my answer, or this is the derivative of ln of x. And that's true, actually. That's our lesson for today. The derivative of ln of x is 1 over x. And we just showed that up above. Or derivative of ln of u being any function, it will be 1 over u times u prime. Okay, so let's try the other questions. Let's start with the first example. Here it says find the derivative of each of the following. So f prime of x would be, we're doing the what? Product rule here. You see two functions, so it's going to be the derivative of the first one times ln of x plus, let me zoom in, x squared times 1 over x. ln of u is 1 over x. Simplify this, I get f prime of x equals 2x ln of x plus x. One of the x's cancels out. So that's your final answer. B, again, it is what? The derivative of ln of anything is 1 over that function times the derivative of the inside using my chain rule. So it will be 4x. I can sit or put it up. Y prime is equal to 4x over 2x squared minus 1. The next one, the derivative of ln is 1 over 1 plus ln of x times the derivative of the inside. The derivative of 1 is 0 and derivative of ln of x will be 1 over x. So if I just want to clean it up, it'll be 1 over x times 1 plus ln of x. Pretty straightforward. And then apply the chain rule for the inside function. That's what it is. So example 2. Before I even start with example 2, I want to talk to you about the change of base formula. You usually don't need it, but when you don't have access to calculator, you do need to know the change of base formula. So let's write this down up here. Log to any base, a of b, is equal to log b. Again, you can write it as any base. I'm going to use common log, or you can write natural log over log of a, or ln of b over ln of a. A was your base, so remember the base goes in the basement, so that's why I wrote it as log a. So that's kind of how I remembered it. Okay, so it says use the change of base formula to find y prime if the function is this. So first of all, I'm going to use my change of base formula. So it's going to be y equals, I'm going to rewrite the formula first. Rewrite the function of the formula. So it's going to be y equals, I'm going to take the natural log of 5 minus x to the 4th over ln of 3. Can I rewrite it as ln of 3 is just a number, right? So ln of 3 times ln of, because it'll help me differentiate better. So now I want to take the derivative of this function. So it'll be y prime is equal to ln of 3 times the derivative of this is 1 over 5 minus x to the fourth times the derivative of the inside, which would be negative 4x cubed. Simplify it, it'll be negative 4x cubed over, you can choose to write it in the front, ln of 3, if that makes it better. I like to write the ln out after because sometimes people think if I wrote it like this, it'll start distributing the 3, which would be wrong, so try not to do that. So finish up the remaining lesson, guys. Good luck.